Good holy sir, we will discuss about the normal distribution. Next. So what is normal distribution? The normal distribution, also known as the Gaussian distribution, is a type of probability distribution that is symmetric around the mean. This means that it demonstrates that data that are closer to the mean are more likely to occur than data that are farther away from the mean. When represented graphically, the normal distribution takes the shape of a bell curve. So this is the example of the standard normal distribution graph. As you can see, yung blue line, yan po yung bell curve. And the straight line sa center is, that was the mean po. Next po. Shape of normal distribution. A normal distribution has symmetrical properties when seen from the peak of the curve, which is the location of the mean. This indicates that the majority of the observed data is concentrated in a region close to the mean, whereas the frequency of the data decreases the farther one gets from the mean. The resulting graph has all the appearance of a bell, with the mean, median, and mode, all appearing at the peak of the bell-shaped curve. This gives the graph is the bell-shaped appearance. Parameters of normal distribution. So, normal distribution or the mean and standard deviation are the two most important metrics to consider when analyzing a normal distribution. Needed po yung mean and standard deviation para ma-recognize or masukat nyo po yung inyong graph po. The form of the distribution as well as the probabilities are determined by the parameters. Altering the values of parameters will result in a different form for the distribution.
Mean. Researchers often use the mean as a measure of central tendency in their work. It is possible to apply it to the task of describing the distribution of variables that are measured as ratios or intervals. The standard deviation. Standard deviation quantifies the range of the data points compared to the mean. It decides how far away from the mean that the data points are positioned and indicates the distance between the mean and the observation. Next. The following is the list of properties that are shared by all forms of normal distribution. First is it is symmetric. A normal distribution always results in a form that is completely symmetrical. This indicates that the distribution curve may be cut down by the middle to yield two halves that are of equal size. When one half of the observation fall on either side of the curve, a symmetric form is produced. Mean, median, and mode are equal. The point with the highest frequency in a normal distribution is the point that corresponds to the center of distribution. This indicates that it contains the most observation of the variable. At the position that falls exactly in the middle of these three measurements is the midway. In a fully normal distribution, the values of the measurements are often equivalent to one another. Next, please, Sky. Next is the empirical rule. When the data are normally distributed, there is a certain percentage of the distance lying beneath the curve that is always the same between the mean and the predetermined number of the standard deviation from the mean. The last one is the skewness and kurtosis. The degree to which a distribution deviates from a normal distribution may be measured using two coefficients called skewness and kurtosis. Skewness is used to determine whether or not a normal distribution is symmetrical, while kurtosis evaluates how thick and tail ends are comparison to the rest of the normal distribution's tails.
We have the example problem. A 100-watt light bulb has an average brightness of 1660 lumens. With a standard deviation of 62 lumens, what is the probability that a 100-watt bulb will have a brightness more than 1800 lumens? We have this problem number 1 of a 100-watt light bulb has an average brightness of 1660 lumens with a standard deviation of 62 lumens. What is the probability that a 100-watt bulb will have a brightness more than 1800 lumens? Our standard deviation here is the 62 lumens, which is this. Our mean or mu is 1600, which is this. And our x is 1800, which is this with the 1800 lumens. Now we will draw a graph. In the graph, our mean or our center is the 1660. Then, we have the x of 1800. In the problem, ang inahanap niya is more than, which is the area that we will find is or we will compute is this part. We have this formula of x of z is equals to x minus mean over standard deviation. Our x is 1800 and our mean is 1660 over the standard deviation of 62. Now we will have a 1800 minus 1660 of equals to 140 over the 62. We will divide the 140 into 62. Now the result is 2.258 or ira-round off ko to siya na 2.26. Px is greater than 1800. Dahil sabi dito is more than. Equals P or Z is greater than 2.26. In the Z table, the 2.26 is 0.4881. We are going to go this 2.2 over 6 here, the 6 part, 0.4881. The whole area of this graph is 1, but yung area na ating hinahanap is this, the more than 1800. So we are going to find this area, we will going to minus the 1 into 0.4881. So 1 minus 0.4881 is equals to 0.5122. Now this is the area of the more than or lagpas ng 1800. Therefore, the probability that a 100-watt light bulb which having brightness of more than 1800 lumens is 0.5122.
So this is the second example. And engineering data analysis examination, the mean grade is 80 and the standard deviation is 10. Find the corresponding z-score of two students whose grade are 87 and 71 respectively. Okay, so this is another example. In engineering data analysis examination, the mean grade is 80 and the standard deviation is 10. Find the corresponding z-score of two students whose grade are 87 and 71 respectively. So this is the formula we are going to use. The z is equals to x minus mean divided by standard deviation. So the x means empirical value and this variable means mean or mu. And this means is standard deviation. So our mean is equals to 80 and our standard deviation is 10. So we have two empirical value, the 87 and 71. So we are going to solve first the 87. So we're going to use this formula. The z is equals to x minus mean divided by standard deviation. So 87 minus 80 divided by 10. So 87 minus 80 is equal to 7 over 10. 7 divided by 10 is equals to 0.7. So the corresponding score of 87 is 0.7 z-score. So the next is another empirical value, which is the 71. We're going to use the same formula, 71 minus 80 over 10. 71 minus 80 is equals negative 9 over 10. Negative 9 divided by 10 is equals to negative 0.9. The corresponding score of 71 is negative 0.9 z-score.
And that's all. Thank you.